Hey, hi everyone. Welcome to today's session of trying to get a deep dive into the Python virtual machine and also a little bit about VNV. VNV have already, which is a virtual environment we have already covered, but we'll again try to correlate so that it just refreshes your mind. My name is Kunal Gautam. I work as a principal architect for one of the MAN companies, in total having 16 plus years of experience. Had my own startup and have spoken at multiple big data AIML conferences around the globe, namely being the Budapest, Korea, Germany, US, and India. So let's look at that. You write a Python program and then you have to execute it. So all you do is you simply say Python and the Python file name. So pretty much something like on these lines. So this is a Python repository, which is a virtual environment I've created. How do I know that? Because you have a configuration file, and it says from where your this is the Python virtual machine is the C Python. This is the version blah blah blah. Right? That's how I know that this is a VNV environment. How do I know that? If I just go to the terminal, you will see that it always starts with this. Yeah, which is pretty much the name of my folder. And that's how I'm able to figure out, hey, this is VN. So why was virtual environment created? Because Python has a challenge that for a given library name, you can only have one version. So in case you have your laptop, the laptop has two repositories, or let's say you're working on two code bases. The first code base requires JSON 2.1 as the version. The second repository requires JSON 2.2 as the version. If they share a common lib, what will happen is, let's say the first repository installs a JSON 2.1. Then the second repository installs 2.2. What will happen is 2.2 will overwrite everything, all the JSON versions in that folder. So now only one of the repos will work. So this was the problem statement. And how did they break it? They break it by saying every repository will have its own Python. All the dependencies will be saved in that directory, which is exclusive to that repository. So now whatever changes you are making on repository 1 has no impact on the repository 2. So let's quickly look at it. If I simply go here in my virtual environment and I say which Python, you can see here it says user Kunal Gao, data science, neural networks, bin Python, which is pretty much the same folder structure. It means that it is figuring out the Python from the bin folder here. Yep. So this is my Python. If I go to the terminal and I do the same, execute the same command, which Python 3, you can see here, this is a completely different folder structure. It means that the Python lib dependency management folder for my OS is very different as compared to what is there for a given repository. The next one sec. Yep. Yeah, here. Yes. So now what I'll do is I'll go ahead and compile a Python program. Again, just to demo you, I have taken a module py underscore compile. This pretty much goes ahead and does the compilation of any Python file that you provide to it. And the profile Python file is nothing but this one. All right. So what it means is I'll just go ahead, execute this code, and it will compile it for me. The compilation is successful. This is pretty much same as running, giving a Python and the file name. All right. What it means is the Python interpreter, as in like after the compilation, it would have generated a Python bytecode for me, just like you have it for Java. Can I go ahead and track that? Answer is yes. Where is it, first of all? If you just go here, the same folder structure, deep neural network, there is a hidden folder whose name is underscore pycache. If you just do a ls on top of it, you can see here that a pyc file has been created. This is the bytecode that is created after compilation, which is consumed by the Python interpreter immediately after this so that it can be executed by the OS to access the whatever the resources of the computer and get it work done. So again, some key callouts. So as a developer, you are writing your Python code, you have a virtual environment. From the virtual environment, whenever you execute Python and the Python file, first of all, it goes ahead, interprets that or compiles that, generates a bytecode, which is a PYC file. The PYC file is taken as an input by the Python virtual machine, PVM, and then it interacts with it gets all the required modules, the C++ modules, which is native to that computer. It consumes that, take this bytecode, executes, and then your Python program is running. Just keep in mind, this the whole process is so simplified that you just provide the Python and the file name. It does all these tasks internally for you, and that's the reason you are not able to differentiate between the compiler and the virtual machine. But just keep in mind, there is a virtual machine which is coming up. Again, what is the Python virtual machine? Python virtual machine says that, hey, you don't have to worry about allocating or deallocating memory. I will take care of it. All you have to do is write the code. I will convert that to the bytecode or the PVC code, and the PVC code I'll consume as an interpreter. As a Python virtual machine, I'll do the memory allocation on RAM by interacting with the OS. You don't have to worry about me about what am I doing. Secondly, the Python virtual machine also says that there is no constraint. I can consume whole of the RAM. Unlike Java, wherein your RAM, your JVM is constrained by the XMX and XMS value. Here, there is nothing like that. Thirdly, is dynamic in nature. You don't have to define the type. The Python compiler can figure out the type for you. Let's go for a quick deep dive just to understand what's happening. So this is your code editor, example PyCharm. You create a Python file, which is your .py file. It compiles, generates a bytecode. It goes to the virtual machine, which is known as the PVM. When you are like actually coding and doing it, all this step is part of the same command, Python and the Python file name. And that's how it interacts with the OS, gets the work done, and your program is running. I just want to show you something that, let's go here. And I just want to show you what is the file type of this Python. Is it a text file, binary file, executable? What is it exactly? So if I just type in this command, file, so you can see here, it's a executable of the Mac, because the Python virtual machine itself was written in C and it has been compiled beforehand. So it's a binary file which is getting executed. All right. If I just want to see it, like just to re-verify, I can just do a vim, which is the command line, let's say, corresponding utility for work docs. So in Windows, you have work docs wherein you can do some changes. On the Linux side, you have a command line utility known as the vim. Does exactly the same thing, text editor. If I just do a vim here, you can see it's all binary data, not human readable data, because this is binary format. So with this, I hope you would have got a good understanding around what's happening at the core of the what's happening at the core of Python. What is a Python compiler interpreter? What is a bytecode? The PVC file that you just saw here, this part, the Python virtual machine, how it enables you not to worry about allocating and deallocating of memory, RAM. It interacts with the OS to get your work done. And last but not the least, it says that you don't worry about a data type. I will figure that out on the fly. Unlike Java, there is no limitation on the size of this virtual machine, Python virtual machine, because the Python virtual machine can pretty much grow to the size of the RAM. In Java, that's not the case. Java virtual machine is limited because you have to provide how big it can grow. It can be a proportion, it can grow max up to the RAM or a proportion of it, but you have to provide that beforehand when you are launching the JVM. So you have to have an understanding, hey, how much memory will be utilized by a given program, and you have to size your JVM appropriately. That's not the case with Python. So Python is much more dynamic in nature. Thanks a lot, folks, and look forward to join you in the next session. Thanks a lot. Nice day.